This video is made for alternative learning experience with a cooperation and teamwork made by the group and its members. A special shout out to John Paul Bellamide, Justin Allen Iso, Shania Mayoro, Al Carueco, Kevin Galvez, Vincent Allen Satimber, and Janice Caspi, along with a special mention to Kyle Galvez in helping editing this video. With that out of the way, let's start with the video. Greetings everyone! It is with great pleasure to make your acquaintance. Allow me to introduce myself. I am Hollow, and I will be your guide to today's lessons, and helping me today is Chappie, the voodoo doll. Now, with the introductions done, let us begin. Today's lesson is all about the rules of derivatives. Now, we will only tackle the basic rules of derivatives, starting with the constant rule. This rule is the easiest one to remember. The derivative of any constant is equal to 0. So, the derivative of 100 is equal to 0. Another thing to note is that the derivative of a function with a single variable, that variable is equal to 1. So, the derivative of 6x is equal to 6 times 1, which is still 6. So now, let us go to the more complex rule, starting with constant times a function. My good friend Shania will possess Chappie here and she will explain the rule.
The derivative of a constant times a function is equal to constant times the derivative of the function, where the constant c can be any real number or expression that does not contain the variable.
Thank you, Shania. Now, to demonstrate, a good example of this is 5x cubed, in which where the cube will be multiplied to 5 while the power will be subtracted, and thus making our answer to be 15x squared. Next on our lesson is the product rule with our new guest JP, aka John Paul Bellamide.
It is a formal rule for differentiating problems where one function is multiplied by another. The rule follows from the limit definition of derivative and is given by.
Thank you, JP. Now, this rule is simple. The derivative of two functions multiplied by one another is where the first function multiplied with the derivative of the second, in addition to the second function multiplied with the derivative of the first function. Now, this may include multiple rules to be used in order to find the answer, but following the steps will give you the answer. Our next guest will explain the next rule. Clap your hands for Justin.
Quotient rule is defined as the quantity of the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared.
Now then, I will demonstrate. To find the derivative of a function divided by a function, we will use the quotient rule, in which the numerator becomes the second function times the derivative of the first function minus the second function times the derivative of the first function, while the denominator becomes the squared of the second function. Whew, that was a mouthful. Next up, the chain rule with Vincent here.
The chain rule is a rule for differentiating compositions of functions. The derivative of a function h of x will be denoted by d times h of x or h prime of x. Most problems are average. A few are somewhat challenging. The chain rule states formally that d bracket f times g of x is equals to f prime times g of x times g prime of x. However, we rarely use this formal approach when applying the chain rule to specific problems. Instead, we invoke an intuitive approach. For example, it is sometimes easier to think of the functions f and g as layers of a problem. Function f is the outer layer, and function g is the inner layer. Thus, the chain rule tells us to first differentiate the outer layer. Leaving the inner layer unchanged, the term f prime g times x, then differentiate the inner layer, the term g prime of x. This process will become clearer as you do the problems. In most cases, final answers are given in the most simplified form.
Okay, now this is a tricky one. So, in order to simplify, I will give an example of 3 plus 6x squared, where the squared will go down and be multiplied with the function, while on the other side, the derivative of the function itself will also be multiplied with itself. So, 2 times 6 will become 12 times 3 plus 6x, which is the function, will become 36 plus 72x, which is our answer and our derivative. Now, with the rules of derivatives now over, we can now go to our next lesson, implicit differentiation, which will be explained by our good friend Alka.
Implicit differentiation is nothing more than a special case of a well-known chain rule for derivatives. The majority of differentiation problems in first-year calculus involves function y written explicitly as a function of x. In mathematics, some equations in x and y do not explicitly define y as function x and cannot be easily manipulated to solve y in terms of x, even though such a function may exist. When this occurs, it is implied that there exists a function y equals to f of x such that the given equation is satisfied. The technique of implicit differentiation allows you to find the derivative of y with respect to x without having to solve the given equation for y. The chain rule must be used whenever the function y is being differentiated because of our assumption that y may be expressed as a function of x.
Here is an example of how implicit differentiation works, where you differentiate each term from the first, second, and third. dy over dx only signifies unknown variables, which we do not know of as of yet. After differentiating each term, you now add them up the same way the function is used to be. So, seeing as x cubed plus 3xy plus 9xy cubed squared is equal to 0, we order them the same way. So, 3x plus 3x dy over dx plus 3y plus 18xy dy over dx plus 9y squared. After that, we just simply transpose and do the following steps. And also simplify our answer. We'll now apply differentiation in a real-life problem. Did you know that you can find an object's acceleration by using derivatives? Here's an example. We will try to find this airplane's acceleration by using this equation, where t signifies time. To find the acceleration at time t, we have to differentiate the position vector twice. Differentiating the first time gives the velocity. Differentiating a second time gives the acceleration. Plug in t equals 1 to solve for the final answer. And with that, the lesson is now over. I hope you enjoyed as much as I did in learning the rules of derivatives and implicit differentiation. And once again, I am Hollow and I bid you farewell.